Hello and welcome to item 8 of the first chapter of Effective Java, which is all about finalizers and cleaners. And item 8 straight up tells you to avoid finalizers and cleaners. And the book actually has a lot to say about the dangers of finalizers and cleaners. And I mentioned this before that finalizers were deprecated in Java 9, and I believe they will be removed at some point. If we go back and look at the object class, we saw that finalize method is a protected method, so it has a yellow color in the outline in Eclipse, and then it has a slash on it, which means it's deprecated, right? So I mean, the whole purpose of finalize was to allow the users, or the ones who develop the code, developer library, basically the developers of library, to try to do some resource management, right? So sometimes a class has to get a hold of some native resources, operating system resources, and obviously when a class goes out of the scope and it's not being used, the best practice is to always release those resources, because by default the operating system, when it hands over some resources to some program, it always puts a cap or a limit on how many of those resources the operating system is willing to allocate to the program, to a specific program. And the best example is file handles, right? So whenever you're using C++, Java, Python, whatever, right? So whatever program you write in any programming language and you want to get a hold of a file, read it, input it as a text, let's say it's a text file, and we want to read the content of the file, what you need to do, you have to go through the operating system, because you want to get a hold of something in the hardware level. And the only way that a program can get access to the really hardware resources, like a file, hard disk, or whatever, it's through the operating system. Operating system is the abstract layer between your program and the hardware, right? And what this means is that your program, let's say you're running a Java program, you have to do some system calls. So it's called a system call. And a system call means you have to use some functions that are provided by the kernel of your operating system. So the kernel of an operating system is those APIs that allow programs to access the hardware, right? And obviously those the kernel is aware of the privileges that a program has, and it can accept or reject the request, right? The kernel calls. So when you, for example, use Java to read a file, it actually, so you create a file input stream, file reader, something of this sort, and all these somehow do a system call through the JVM, right? JVM is a program written in C++ and compiled. So, and then your JVM depends on the operating system you use, right? You cannot use JVM that is specific to Windows on Mac OS, because the system calls are not compatible. Even if the CPU architectures are compatible, the definition of the platform for a program is not just the CPU architecture, it's also the operating system that sits between the hardware and your program, right? And so the whole business of finalizers was resource management. And the reason that I'm emphasizing resource management is that Java has automatic memory management, right? So garbage collection is a program runs in parallel with your application. It has its own threads, and it tries to pause your application for some time and scans the whole Java heap and see if there is a dangling reference. If an object is abandoned, whatever, then it cleans up the Java heap and then also compacts the Java heap, right? So memory management was automatic, and it was one of the main attractive things about Java at the time, right? And then the problem again was that JVM provides some access to native resources, provides the system calls through standard JDK APIs, right? File handling, reading files, writing to files, writing to the system output, right? System.out.println, for example, or system.in, getting the input from the keyword. So Java's abstraction was streams, file streams, or streams themselves, like in and out, and then Java provides under the hood. Java provides system calls or kernel calls to the operating system. And then the problem is that sometimes you really want to let the developer also manage some native resources. For example, you want to write some code in Java that can talk to some hardware, specific hardware. Let's say you're using a USB bus or GPIO bus, this sort of things. Obviously, the JDK doesn't provide anything by default, so it's up to developers to create their own libraries. And then talking to USB port, this is something that is not related to memory management, right? So accessing a USB port is about resource management, because you have to access, the operating system has to provide a path to that USB port, right? So it's some sort of native resource that you have to access it. And then the question is, when you access some native resource, when your object is destroyed, you want to release that. Tell the OS, hey, I'm done. This class is done. And then before the garbage collector deletes that object from the Java heap, you want to make sure that, that all those resources are returned back to the operating system. And the problem is that the whole garbage collection business in Java, it's not deterministic, which is what makes all the confusion about finalizers, right? So finalizers were supposed to provide some sort of deterministic way of resource management, releasing resources, but then the problem is that there is no guarantee that when the finalizers are going to be run. That's why the very first point that the book brings up is finalizers are unpredictable, so undeterministic. That's the main problem. Often dangerous and generally unnecessary. So if you're not doing any code that requires native resource management, you don't really need to worry about memory management. So no finalizers, no cleaners whatsoever. Now, obviously, cleaners are the concepts that were introduced way after finalizers, right? So these are actually relatively new. As of Java 9, finalizers have been deprecated, but they are still being used for Java libraries. And the reason is, you probably can guess, because of backward compatibility. Java has always kept its promise of backward compatibility, and it's very proud of this backward compatibility. The Java 9 replacement for finalizers is cleaners. And cleaners are basically a whole, they require a whole lecture for their own. So I'm not going to go into details of what cleaners are and how to use them. Cleaners are less dangerous than finalizers, but obviously they are more complicated, but still unpredictable, slow, and generally unnecessary. So beware, finalizers or cleaners are not Java's equivalent or Java's analog to C++ distractors. Now, what is a distractor in C++? In C++, whenever you create an object, you call the constructor, right? But then C++ also provides another API for a class, which is called a distractor. So it's exactly the constructor with which is a tilde sign comes after the name of the constructor, which is distractor. And distractors are a deterministic way of releasing the resources that object, that class holds. And whenever a class goes out of the scope, the destructor of that class is guaranteed to be called. That's part of the C++ language, right? That's not part of a library or something like that. That's a guarantee that the C++ language provides. And therefore, you can do any sort of cleanup that you need to do in the destructor, because you know that when the object goes out of the scope, it's not being used anymore. So we want to do some cleanup if we have to do. And then this includes both memory management and resource management. Memory management is obvious. If the class holds some pointers to some objects in the heap, then when those pointers go out of the scope, you want to also destroy the resources on the heap itself. If obviously objects on the stack in C++, it's automatic management of memory. You don't need to worry about that. Resource management is always kind of manual. You have to do some cleanup in the distractor. So finalizers and cleaners are not analog to these distractors, and the main reason is that they're not deterministic. You don't know when the finalizers are going to be run, and there is actually no guarantee. Maybe the JVM decides that, okay, this application is going to terminate anyways, so I don't need to call the finalizers. I just terminate the process altogether. One shortcoming of finalizers and cleaners is that there is no guarantee they'll be executed promptly, or not even promptly. It's not deterministic, right? Non-deterministic destruction of the objects is the problem. You should never do anything time critical in a finalizer or cleaner. That's kind of obvious based on the discussion. The promptness with which finalizers and cleaners are executed is primarily a function of the garbage collection algorithm. Now, obviously, the JDK, JVM, they provide different kinds of garbage collectors, and the algorithms that each garbage collector uses is different. And the runtime class and the system class, they provide the GC call. So they kind of provide an API. For example, if you look at the runtime, there is a native method called GC. But again, even the specification of this API is not clear, that it's not a 100% guarantee. So there is no strong guarantee that you can deterministically run GC. All right, and that's the main problem with all these business about finalizers and cleaners. So let's head to Eclipse and try to see what we can try to look at finalizers a little bit more. So in my Eclipse, I'm going to create a new package. Let's call this item 8. And here I'm just going to create a class, let's say my class, right? And this is going to have double or maybe int x, and I'm going to have a public constructor, my class, and then int x, and then this dot x equals x, right? So there is nothing new. And then, but we know that finalize method is a protected method from the superclass object. So let's do override implement method from the object. I'm going to override the finalize, right? This by default calls the super finalize, and the super finalize doesn't do anything. It's an empty, right? So the object finalizer class doesn't do anything, which is a shame. They could do something natively, for example, so that but again, this task of finalizing objects and reclaiming the Java heap memory is just GC. So GC doesn't care. I mean, GC tries to call this finalize method, and but GC does its own thing, right? So let's say we just do a sysout here, calling finalize in my class, right? And maybe we can also say x equals plus x. Just see that if we have different instances, which instance is actually this message is printed for. And we're going to have a test class. So class test. Let's have a main method here. And so what I'm going to do, I'm going to have a method test1. So public static void test1. What are we going to in test1? Obviously, I'm going to create an instance. MC1 is new my class. Let's say with 1, and I'm going to also create a new instance MC2, right? And I'm just going to run this. Now, obviously, we know that we're creating these objects in this method, and the scope of this method is here, right? So here's where the scope ends. So the scope of test1 ends. Now, if you're familiar with C++, you know that at this point, because these objects go out of the scope, the destructor is called always. This is a guarantee, right? This is something that the language guarantees. But then Java doesn't guarantee that it's going to run the finalizer. So finalizers are not Java's analog to destructor. So let's run this and see what happens. Nothing happened. So nothing was printed. It means that the finalize method was not called. Why? Because this was a very simple application, and when we ran the JVM it starts with some memory, right? Some initial memory from the operating system, and then JVM saw that, okay, we're creating these two classes. These two classes, they're just like 8 bytes, right? So they don't need much memory. And then when it hits here, the scope of the main, JVM decided that, okay, there was no point in calling the GC and doing any memory cleanup, because we have enough memory to continue, and the program is terminating. So what's the point of running GC, right? So this helps your Java application go faster, right? Because you're not doing any extra calls to a destructor. So this is something that the Java sometimes benefits from, and sometimes if you have a short-lived application, sometimes you really don't want to waste time calling destructors when there is no point. Let's say you have, I don't know, 100 gigabyte of RAM. you allocate 50 gigabyte to your JVM, and then what's the point of, if your application maybe only uses a few gigabytes, what's the point of cleaning up the memory, right? Now, native resources like files, this kind of stuff are always have to be cleaned up, because there's always a limited amount of file handlers that the operating system can allocate to your application, right? But memory, just occupying memory, it doesn't really matter if you have much more than enough memory for your Java heap. You don't really need to worry about. And that's good, because then if you have enough Java heap memory, then you're allocating objects. Allocation is cheap if your classes are small. And if you're not running GC, then your application can actually go could be as fast as your C++, because you're not wasting time with cleanup and calling the distractors, right? But then let's say now this class, we really want to call the finalizers. How do we do that? Obviously it's not deterministic. So let's say we try to say, hey, we give a hint to JVM to call the GC. So get runtime GC, and obviously it's recommended to use the system class instead of gaining access to, and this you can assume that it just gets the runtime instance, which is a singleton, and calls the GC, but it makes more sense to call it from the GC, right? And then if you run this, again, there is no guarantee that the GC will run. There is no guarantee that the finalizer will be called at this point. It depends really at this, if you go with the system GC route, it really depends on implementation of the JVM. There are different vendors of the JVM. There are different implementations. I'm using Hotspot JDK 15, so I believe it has some sort of 80%, 90% guarantee that the GC will run. And as you can see, the GC was run. So in the recent version of the JDK, Hotspot JDK, I think this is a good guarantee, but again, it's not recommended. Do not rely on this for a deterministic call to finalizers. That's a bad practice, right? So this is a bad practice to rely on system.gc. Right, so we shouldn't do that, and it's always best to figure out. There are obviously there are alternative ways that the JDK provides. Otherwise, Java would run in serious problems. So let's head to our PowerPoints and continue with this item. So we said that finalizers, just try to avoid them as much as possible, and the language specification makes no guarantee as to which thread will execute finalizers. And this is another problem. So the first problem is that even if you're in the same thread, let's say you're in a main thread and you want your objects to be cleaned up when they go out of the scope, but then it's not deterministic, so you don't know when the finalizer is called. You also, if you're doing multi-threaded applications, your code is multi-threaded, it's also no guarantee that which thread will execute the finalizers. Cleaners are a bit better than finalizers in this regard, because class authors have control over their own cleaner threads. But again, writing the code that utilizes cleaners is more complicated, and it just makes your code or life harder, and then that's not the essence of Java. Java came along because people were kind of getting tired of complexity of C++. So the philosophy of Java was to make life much easier for developers. But then when you go this level deep into resource management and stuff in Java, it gets complicated. But cleaners still run in the background under the control of the garbage collector. So there can be no guarantee for prompt cleaning, right? And I will show you where these cleaners are. There is a package, I believe, inside Java Lang. It is entirely possible, even likely, that a program terminates without running them on some objects that are no longer reachable. So if it's about so JVM looks at how much heap is allocated, and again, the problem is that GC, the core function of GC, is memory management, not resource management. Unfortunately, the problem is that everything has been handed to GC in terms of both memory and resource management, and in my opinion, that's a mistake. there should have been another application, let's say garbage collector and resource collector or something else, RC for example. So kind of the JDK should have separated these two tasks with two separate applications, garbage collector GC and resource collector RC for example. And then in that case there was no absolute confusion, because memory management in Java is still automatic, right? So your class goes out of the scope, there is no pointer or reference on the stack that is pointing to that object, so that object will be garbage collector. The problem is always what happens to that the native resources, let's say a file handle or something that class is holding on to. What should we do? And that's not memory management, that's resource management. So again, cleaners were introduced to kind of help with this idea, but it's always a problem. So the solution that Java provided eventually was, I believe from JDK 7, was try with resources. So and then auto closable. So auto closable means you mark your class as auto closable, which means that which indicates to the user or the client of your code that this class is managing some resources. Again, it's a resource management problem, not a memory management. Memory management in Java is still automatic, right? You don't need to worry about that. But resource management is not, because the operating system will not hand infinite number of resources. Whereas if you have infinite amount of heap and allocate half of it, I mean infinite amount of heap to the JVM, operating system has no problem doing that, right? So memory management is not an issue. So you should never depend on a finalizer or a cleaner to update persistent state, right? So again, this is something I'm not going to go into details. You can read more about this, right? So we talked about system GC, and system GC is a static method in system class, which just delegates to a call to the GC method, which is a native method in the runtime class, and runtime is a singleton, so you get access to the unique instance of the runtime through the get runtime, which is a static method, right? And again, GC in the runtime is a native. And system also has another method, run finalization, right? So runtime, get runtime, run finalization. Again, system class delegates this to the runtime class. And run finalization in the runtime class is shared secrets dot get Java lang ref access. This is not reflection, this is ref. These are the object references or pointers. Run finalization. So what's the difference between running GC, system.gc, and system.finalization? Let's head to Eclipse and try this. So in Eclipse, we put the system GC here. I'm going to remove this. Let's say we create the so if these two objects go out of the scope, I'm going to make a call to the system GC, and no finalizer is called because these objects are still in the scope, right? So if at this point we make a call to GC, these two objects are not out of the scope. But again, if we put this here, now we have two objects that are out of the scope. They can be reclaimed. Yes. But instead of doing this, what if before these objects go out of the scope, I make a call to run finalization? Let's see. Nothing happens, right? What if I move this in the main when these two objects are out of the scope? And nothing happens. So this seems to not do anything. It says that runs the finalization method of any objects pending finalization. Calling this method suggests that the Java virtual machine expend effort toward running the finalize method, but here we see that there is no effort was done by the JVM, because JVM decided that there is no point. The application is main thread is terminating, so nothing to do. But GC seems to, at least in my JVM, which is hotspot, seems to provide a stronger guarantee that it's going to run finalizations. And again, system GC, system run finalization. In our example, it didn't do anything, run finalization, and then system GC seems to provide a stronger guarantee. So the auto closable concept is actually the topic of the next item in this chapter, which is So the book says don't use finalizers, and then in the next item it provides the solution if we are not supposed to use finalizers and cleaners. So what else should we do, right? And let's go back to Eclipse and try to look at the cleaners. So again, if you look at the JDK in the Java base, Java lang, you see there is a reflect. This is the reflection API, but they added this new package, ref. This is the reference, everything related to references. And again, references are glorified pointers. So this ref package deals with the references and how to clean up resources, right? So there is a cleaner class. And what you do, so cleaner is a class that has a marker interface cleanable, right? And it has a method clean. What you do in your class, you create a cleaner class. So private static final cleaner, new, or you basically say cleaner dot create. Let's see, Java language for cleaner. Cleaner, it's a private constructor, and it has a public static method cleaner create. And create thread factory, kind of you have to go through the API to see what the use case of this here, and then register, right? So cleaner.create, and then so private, so cleaner, let's call this cleaner. So we create this cleaner, and then the problem is it's a bit more complicated because you have to separate the state of the object with the implementation of the object. You kind of need to have another object that holds on to the state, right? But then what we can do is cleaner basically has a cleanable interface. So what happens if we say that this implements cleaner.cleanable, and then we're going to add the unimplemented method clean, and then what are we going to say? We're going to say that cleaner dot what we're going to, so I'm going to copy and paste this calling clean, and then here in the constructor we're going to say that this cleaner register this object with the action this, with the runnable this, and then actually we're going to, it accepts a runnable this dot clean, I believe. So something like that. Again, this is not the way to go about this cleaner. I'm just showing you that the cleaner is a class in the Java lang ref that is if you really want to choose between finalizers and cleaners, it's recommended to use cleaners. But again, basically it also makes your code complicated, and I recommend you to read this item in details in the effective Java book because the book has more details about, or examples about, how to correctly use cleaners. But in our case, I just try to do some cleaning. Let's see, nothing happens. If we MC, let's say, let's see if we can return MC1. So my class. Okay, and then here then let's see what happens if we say mc1.clean. Let's see if something happens. Let's return void here. It calls the clean method, and so what's the point of this register? And again, the idea here is that you encapsulate the state of the object, this object, into another internal object. So you have a private static nested class, for example, that encapsulates the state and then register that state with the cleaner, right? So you don't go and implement the cleanable, something like that. And then again, these cleaners were added since Java 9 when the finalizer was deprecated, but they have a relatively more complicated API than the finalizers. So I hope you enjoyed this item. Please stay tuned, and I'll see you in the next one.